Okay, so let's go through this review. In case you have more questions, you can come back and look at this. So this is our limits quiz review. For 1 through 9, they give me this graph. And the first one is asking me about a function value, not a limit, a function value. So the function at 2, they want to know what is actually happening at 2. So if I look at 2, there's really 2 points at 2, but this one is an open circle. This one's a closed, so the actual function is at the closed one. So what's happening at x equals 2? Well, the function equals 2. So it's 2. I'm going to skip down to number 4 and do the same thing with it because it's also asking about a function. For some reason, I feel like going back and forth between a function and a limit, and then a function and a limit, that tends to mess people up and they start making mistakes. So if the first one is a function value one, I would go ahead and do all the function value ones at the same time. So the function at 4, which is right here, the only point there is this point that's at 2, but it's an open dot. So that is not the point there. So the function at that point is undefined. So it's not that it doesn't exist, it's there, but it's undefined in that case. Okay, then my last one is the function at 6, number 9. So if I look at 6, again, there's an open point right here, but there's a solid point right there. So my function value there is 3. Okay, now let's do some limits. So the limit is checking to see what's happening from the left and right. So on this one, it's asking the limit as x approaches 2, so right here. And it doesn't say from which side, it just says the limit as x approaches 2. Well, this one, from the left side, it's 1, and from the right side, it's 2. So those don't match up, which means that limit does not exist. So if you put does not exist, that's a limit situation. If you put undefined, that's a function situation. So make sure you keep those separate. All right, number 3, the limit as x approaches 4. So here's 4. We know the function value there was undefined, but the limit, it looks like from both directions, it's going to 2. So if I had to predict, I would think that the function was going to be 2 there. So the limit as x approaches 4 is 2. Okay, number 5, this is that notation that I introduced. It was kind of new today. So this plus sign right here, if it says the limit as x approaches 2 from the right, that's what that means. That plus sign means from the right. This one has a minus sign, so it means from the left. So this one is asking about 2, the limit as x approaches 2 from the right side. So from over here, I'm going to check it. That looks like it's going to be the same as the function value, which was 2. But if I'm coming from the left, like on number 6, this one looks like it's going to 1. So from the left, it looks like it's 1. So because these two don't match, that limit just as x approaches 2 does not exist, because from the left and from the right, it doesn't match. Okay, the next one says, what's the limit as x approaches 6? From the left, because it's a minus sign. So from the left, as x approaches 6 from this direction, it looks like it's going to be 2. And then they're asking, okay, well, what's the limit just as x approaches 6? Not from the left or the right, but just 6 in general. Well, from both directions, it looks like 2. The function value is not 2, but that doesn't matter. The limit looks as if it is approaching 2. Okay, so there's all of those. Then we get into evaluating these limits analytically. So we're going to have to use some algebra here. So on this first one, if I take x equals 2 and I just plug it straight in, my denominator would be 0. Now on the quiz, you do not have to show me that work. You don't have to show me that it's going to be an indeterminate form like you did on the homework. So instead, I'm just going to go ahead and factor the top to see if something will cancel, because I can't just plug it in the way that it is. If I factor the top and it cancels, that means that one of those has to be x minus 2. I'm really hoping that that's the case. So I'm thinking, can I get a factor of x minus 2 out of this? Well, I could if this was a 6, and in order to make a positive 4, that would be a positive 6. 6 minus 2 is 4. Okay, so then this cancels. Notice I left my limit notation because I hadn't plugged anything in yet, so I have to keep this notation with this statement. Then on this next one, I'm going to plug that in, so I no longer need my limit notation. So I'm just going to take 2, plug it in right here. That's 2 plus 6, which is 8. And then I'm done. All right, the next one, same thing. So if I took my 1 and I plugged it in, 1 squared plus 5 minus 6, that's going to give me 0 again. So I don't want 0, so I'm going to factor. First, I'm going to write my limit notation. Sorry. I'm going to factor my top, factor my bottom. So the top, an x and an x, I need factors of 4 that would give me a negative 5. Well, that'd be a negative 4 and a negative 1. That would give me negative 5. The bottom would give me factors of 6 that would give me a positive 5, but it's a negative 6 here. So these signs have to be opposites. One has to be plus, one has to be minus. So if I do that, then factors that would give me 5 would have to be a positive 6 minus a 1. So be careful on that one, because 2 and 3 would give me 5, but not if my signs are incorrect. So that's not okay. So this will cancel. So now I'm going to go ahead and substitute this in. So this would give me 1 minus 4 over 1 plus 6, which is negative 3 over 7. I would just stop right there. Okay, the other side of this, I've got some bleed through, so hopefully you can see it. All right, so on this one, if I take 5 and plug it in, 5 squared is 25, plus 5 minus 30, that would give me 0 again. So I need to factor again. Keeping my limit notation, factoring. If you need a brush up on factoring, there are tons of resources online. So if you need to go practice a little bit of that or watch some videos, that would help. X and X, this is actually called a perfect square trinomial. I don't know if you remember that, but 5 times 5 gives me 25. And if they're both minuses, that gives me negative 10. So this is really like x minus 5 squared. And then on the bottom, I know I'm going to need an x minus 5, so I'm going to go ahead and write that down. The other one would have to be a 6 then, because 5 times 6 gives me 30. I need negative 30, so this would be positive. And that would give me a 1 in the middle if I added those together. Okay, so these cancel. Plug that in. I get 5 minus 5 on top. 5 plus 6 on bottom, which gives me 0 over 11, which is just 0. If there's a 0 on top, 0 divided by anything is 0. That's not undefined. That's just 0. Okay, this one, if I plug this one in the denominator, 2 squared is 4, minus 3 times 2 is 6, plus 1. That does not give me 0 this time. So I'm just going to use direct substitution. So that's something, we talked about it in class, but we can talk about it again here. That so maybe you didn't notice that right away. And if you didn't, what you would have found is that this top one is not factorable. So then that should have been a red flag that you need to be doing something else. But I'm just going to automatically substitute it in. So 2 squared plus 4 times 2 plus 7 over 2 squared minus 3 times 2 plus 1. Well, that gives me 4 plus 8 plus 7. The denominator is 4 minus 6 plus 1. So this is going to give me 19. This is going to give me negative 1. And that simplifies to negative 19. Okay, these next two are rationalizing the numerator problems. So anytime you see these square roots, that's probably going to be one of those problems. So I'm going to multiply this by the same thing. So the square root of 2 plus x, and then the square root of 2 is going to stay the same. But in the middle, it's going to be plus instead of minus. So right here is a minus sign. You do the opposite sign right here. Everything else stays the same. So same thing with this bottom. Square root of 2 plus x plus square root of 2. Okay, so this is what's going to happen. My limit as x approaches 0 stays the same, but now I'm going to multiply this out. So let me use a different pen here. So if I take this times this, the square root of 2 plus x times the square root of 2 plus x, those square roots just cancel each other out. It's like me saying I've got the square root of something squared. That cancels. So the only thing that's left is what was inside the square root. So 2 plus x. The next two terms, so this one right here and this one right here, those will cancel each other because it's the same thing except one is plus and one is minus. So then my last one is the only other one I care about. So it's going to be a minus because that one was a minus. And then in this case, I have a square root of 2 times a square root of 2. Square root of 2 times the square root of 2 is like saying the square root of 2 squared, which is just 2. And then that's all over this stuff. So the x that was there to begin with times all of that stuff I multiplied it by. And then I'm going to simplify. So a 2 minus a 2 is 0. Then, so I get x, let me write this out. You don't have to write this step if you don't need to. But I end up with x over x times this. So again, I end up with this canceling. The x's cancel, which means I'm left with the limit as x approaches 0 of 1 over this mess. Okay, so now if I plug 0 in right here, the square root of 2 plus 0 is just the square root of 2. So I end up with the square root of 2 plus the square root of 2. Well, that's 2 of those square roots of 2. The numerator stayed 1. That one was pretty messy. All right, the next one, same thing. I'm going to take my top times the square root of x plus 1 plus 2 and the bottom times the square root of x plus 1 plus 2. Okay, so the top, let me write my limit notation. The top is going to be x plus 1. And then my last term is minus 4. So that's the only two I have to worry about is my first two times each other and my last two times each other because the middle two will cancel out. The bottom, I'm just going to write down what I have. So that x plus 3 right here, or x minus 3, I'm going to leave that x minus 3, but I am going to put parentheses around it because it looks a little odd. and then x plus 1 plus 2, like that. And then this right here, this statement right here is the same thing as x minus 3 if I put these two together. So this cancels with this. And that happened on the homework as well. Okay, so that means I have the limit as x approaches 3 of 1 over the square root of x plus 1 plus 2. So now if I substitute in my 3 right here, I get the square root of 3 plus 1, which is the square root of 4. The square root of 4 is 2. So I get 1 over 2 plus 2, which is 1/4. Okay, last one. If I use direct substitution, so this one I'm seeing factoring again happening here, but just in case, if I plug in my 1, that'd give me 2 plus 1, which is 3, minus 3 is 0. So that one is not going to work with direct substitution. So I'm going to go ahead and factor. So this is kind of considered my tougher factoring because there is a term in front of x squared, there is a coefficient there. So because of that 3 and that 2, that makes it a little bit tougher to factor. So 3x times x will give me 3x squared. I need -2, but I need things to add up to a -1. So if I put a 2 here, this would give me, and a 1 here, this would give me 3, and this would give me 2. So if I have a -3 plus 2, that gives me -1 in the middle. And then down here I have a 2x and an x. I'm feeling pretty good about the fact that I need that to be the same, since these definitely are not the same. So if that's a -1, this one would have to be a +3. And then check your inside gives me 3, outside gives me -2, so that does work. That gives me 1 in the middle. Okay, so these cancel. So I have the limit as x approaches 1 of 3x plus 2 over 2x plus 3. Go ahead and substitute in at that point. So this is 3 times 1 plus 2 over 2 times 1 plus 3. So I get 5 over 5, or just 1. Okay, hopefully that helps for the quiz. If you have any other questions, please let me know, and I will get back with you.